j 0.15 per unit. R is equal to 0.05 and X is equal to 0.15. Shunt admittance is neglected. Means the transmission line is having negligible shunt admittance. So it is possible if your length of the transmission line is sufficiently small and voltage level is less. So means each line is having no shunt admittance. So each line is having only the series impedance. Means the conductors of the similar length, we can say the same type of conductors and having the same length, we can say. Then all the conductors is having the same impedance. So here we have assumed a simple problem in order to understand that how we can apply the Gauss-Seidel method. So its shunt admittance is neglected. Now in the system we also have a PV bus. For the PV bus we need the reactive power limits. So reactive power limits is given for the PV bus. These are the limits for the reactive power. Q2 minimum is equal to 0.2 per unit and Q2 maximum is equal to 0.6 per unit. So based on this information, we have discussed, earlier we have discussed the steps for the Gauss-Seidel method. So what steps we have discussed? The first step was input the data. First step was input the data. So what information we have? We have the type of the buses. So we can give the information regarding that this is the generation at the bus, this is the demand at the bus, okay? And this is the voltage level at the bus, this is the type of the bus. Okay? Then we also need we have given the transmission line data. So series impedance of each line is given. So we can give it as an input. So because we are solving this through the mathematical calculation on the book, on the notebook, so it is not easy to process all the iterations. So here we are solving this problem for only the one iteration. We will solve this problem for only the one iteration. So for this, the second step we need is to formulate the Y bus matrix. Okay. Second step is to formulate the Y bus matrix. So the transmission line information is given. So from this we have the Y11. What will be the value of Y11? Two transmission lines are connected at bus number 1. So series impedance of each line is 0.05 plus 0.15. 0.05 plus 0.15 for this line and 0.05 plus j.15 for the second line. So the total Y11 will be equal to sum of the admittances which are connected at bus number 1. So this is equal to your 2
minus j6.
2 minus now this is the value, this is the impedance value. Z is here, small z is given in terms of R plus Jx. So your R is 0.05 plus J of 0.15. So this is the impedance. We are formulating the admittance bus matrix. So we have to convert this into the admittance value. So admittance value will be equal to Y is equal to 1 upon Z. This will be equal to 1 upon 0.05 plus J of 0.15. Okay? So we can convert this into 0.05 minus of J 0.15, 0.05 minus of J 0.15. Okay? So what is the value we have? We have the A square minus B square here. Okay? So from this we have the value, this value. Admittance value will be equal to this value. So adding the admittance 2 minus J6, the admittance value will come with 2 minus J6. So 2 minus J6 for one line, 2 minus J6 for the second line, total is equal to 4 minus J12 for the first line. Similarly, the second element Y12. Y12 is a minus of the admittance which is connected between the bus 1 and 2. Okay? So the admittance of this line is 2 minus J6. So minus of this is equal to minus 2 plus J6. Then Y13. Y13, 1 and 3. There is no line between 1 and 3. So this value is equal to 0. Similarly, 1 and 4, there is no line. So this value is equal to 0. Okay? Then 1 and 5. 1 and 5, this line. So this admittance is equal to minus of this admittance is equal to minus 2 plus J6. Similarly, we can formulate for all the other elements also. So this is the our Y-bus matrix. So Y-bus matrix, we have the I on this side and K is on this side. So we have the values. This here K is equal to K is starting from 1 and K is reaching to the 5 here. I is starting from 1 and it is reaching to 5 here. So first element I is equal to 1 and K is equal to 1. So Yik for the first element is equal to Y11. Okay? Y12, Y13, Y14, Y15. Then I becomes 2. Okay? I is 2, K is 1, I is 2, K is 2, Y22. Similarly we have that. So we have formulated the Y-bus matrix. Then we have to assume the data. We have to, next step, assume the data. Okay? Now for the first bus, V and delta is given. V1 delta given is, so this is given. V1 delta 1. And we have to find P1 and Q1. For the second line, for the second bus number 2, given is P2. P2 is equal to PG2 minus PD2, which is equal to 2.0 minus 0 is equal to 2.0. And V magnitude is given, V2 is given 1.02. So we have to find here, we have to find the Q2 and delta 2. For the bus number 3, PG QG is 0, PD QD is given. So we have the P3, from this P3 is equal to 0, PG is 0 minus 0.5 minus of 0.5, Q3 is equal to 0 minus 0.2 minus of 0.2. So here given is P3. P3 is given, Q3 is given, and we have to find V3 and delta 3. Then we can find the P4 and Q4. So P4, Q4 is given, and we have to find P4 and delta 4. We have to find P5, Q5 which is given, P5, Q5 is given, and we have to find P and delta 5. So we have to find this value. We have to find this value. So in case of Gauss-Seidel method, we are using the voltage equation. So in case of voltage equation, we are unable to find P1 and Q1. So we are not finding, initially we are not finding this P1 and Q1. We will start from the
Q1
from the bus number 2. Okay? So we have the voltage equation. V2 is given by P2 minus of JQ2